Okay, so in 8.1 part 2, we're going to solve these systems of equations using the um, addition method. All right, so in the addition method, basically at some point you're going to add those equations, and then when you add them, one of the variables will disappear. You'll get a solution for a variable, and you're going to plug it back into one of these equations, and you got the other. That's all it is. But when solving a system by equation using the addition method, you have to make sure that whether you eliminate the x's or whether you eliminate the y's, that these coefficients are going to be opposites of each other. So you got to pick a variable you want to eliminate. It does not matter which variable. So I'm going to go ahead and eliminate the y here. It did not matter. So I'm going to go ahead and rewrite it. So negative 4x plus 9y equal 9. And then x minus 3y equal negative 6. Okay, so you're going to find the least common multiple of these coefficients of the y. So the least common multiple of 9 and 3 is 9. So 9 and 3 equals 9. So basically you want these coefficients to be a 9 and a negative 9. Well, this one's already a 9, so I need this to be a negative 9. And so in order to get this to be a negative 9, I have got to multiply both sides by 3. So both sides of this equation by 3. And so then I'm going to get this. I'm going to get my new system. It's going to be negative 4x plus 9y equal 9. And then distribute. 3 times x is 3x. 3 times a negative 3y is a negative 9y. And then 3 times negative 6 is a negative 18. Okay? All right, one thing I forgot to mention was that when solving a system by the addition method, make sure that the equations are in standard form. So all your variables one side, and they're all aligned. See, they're all aligned. The x's are grouped together, the y's are grouped together, the equal sign, and then the constant. Okay, so make sure it looks like that. Okay, now I can add, and the reason I can add is because the coefficients of the y's are both opposite, so that means that when I add them up, this is 0. So negative 4x and x is a negative x equal, and then 9 and the negative 18 is a negative 9. I remember trying to get x by itself, so this is a negative 1x equal negative 9. So divide both sides by negative 1. Negative 1 divided by negative 1 is 1. 1 times x is x, so I get x to be positive 9. And negative 9 divided by negative 1 is a positive 9. So far my solution, the x-coordinate is 9. Okay, now, just like with substitution, once you find one of your solutions, one part of your solution or one coordinate, you go back and you substitute, you back substitute. So I'm going to take x equal 9, I'm going to go into one of these equations up here, and I'm going to, wherever I see the variable x, I'll plug in 9. I'm going to go ahead and use the second one since this is just an x. So I'm going to get, so I'm back substitute, so I'm going to substitute x equal 9 into x minus 3y. It did not matter, you could use the top equation. Alright, so x is 9, so I get 9 minus 3y equal negative 6. Subtract 9. 9 minus 9 is 0. 0 minus 3y is a negative 3y equal, and then a negative 9 and negative 6 is negative 15. Getting y by itself, right now multiplying by negative 3, the opposite is to divide by negative 3, both sides. Negative 3 divided by negative 3 is 1. 1 times 1 is 1 times y is y. And then negative divided by negative is a positive. 15 divided by 3 is 5. And so your solution is 9, 5. And again, you can check. So if you go back where we see the variable x, you plug in 9. And where we see the variable y, you plug in 5. So negative 4 times 9 is a negative 36. 9 times 5 is 45. A negative 36 and a positive 45 is 9. But you got to check the other one as well. So 9 subtract 3 times 5. So 9 subtract 15 is a negative 6, and that's what you wanted. Okay, so let's do the second one. So again, choose a variable you want to eliminate. So let's just go ahead this time and eliminate the x's. So let's eliminate the x's. Alright, so basically you're going to find the least common multiple of, alright, the coefficient of x's right now are 4 and 5. So the least common multiple of 4 and 5 is 20. So I need both of those to be 20s, one being positive, the other being negative, because I need them to be opposites. Because when I add two numbers that are opposites of each other, I get a 0. So I want to eliminate the x's. Okay, so let's see. I'm going to go ahead and rewrite the equation over the system. This is what we get. All right, and so 4, you got to figure out 4 times what's 20. Well, 4 times 5 is 20. And then 5 times what's 20? Well, 5 times 4 is 20. But remember, I need one of these to be negative, so it does not matter which one. Here, it didn't matter because I didn't have to worry about that because the y's, one was positive, one was already negative. So they already had a positive and a negative. Here, these are both positives. So let's just make this one negative right here. Okay, so then I'm going to get the new system. You remember we're going to distribute now. Same thing here. So negative 5 times 4x is a negative 20x. Negative 5 times a negative 3y is a positive 15y. And negative 5 times a negative 16 is a negative 80. All right, so always double check if you're not sure. 16 times 5 is 80. All right, and then distribute the 4. 4 times 5x is 20x. 4 times 2y is 8y equal, and then 4 times 3 is 12. All right, so remember, a mistake people make is usually they forget about multiplying the right side as well. You multiply everything by this number. Now I can add, because when I add, a negative 20x and a positive 20x is 0. So they are eliminated. The variable x, the terms x's are eliminated. Now 15y and 8y would give me, 23y equal. And then 80 plus 12 is 92. And then to get y by itself, I'm going to go ahead and divide both sides by 23. And so 23 divided by 23 is 1. 1 times y is y. So I get y to be 92 divided by 23 is 4. All right, so your y coordinate of your solution is 4. So make sure you put the 4 in the correct spot. So that's your y coordinate. All right, and then just like we did this one, you're going to substitute. So you're going to substitute y equal 4 into, and you just got to pick one of these equations. It doesn't matter which one. Let's just go ahead and use the second one. 5x plus 2y equal 3. It did not matter. You can use the first one if you wanted to. So again, where we see the y, you plug in 4. So I get 5x plus 2 times y is 4, equal 2. So I get 5x. 2 times 4 is 8, equals 2. Make sure I'm doing this right. So 4, looks like I'm going to get a fraction here, but I'm just verifying. So let's see. Y, substitute y 4. So 5x, oh, that's a 3. Okay, sorry. So always double check. So 3, that's a 3 here. I messed up. All right, then subtract 8 from both sides. I get 5x equal negative 5. Dividing both sides by 5, I get x equal negative 1. All right. Now, you can have fractions. There's nothing, I mean, it's possible. I just made sure that when I did these worksheet that your solutions, the coordinates were integers. And so when I realized I was getting a fraction instead, I figured something was wrong, and this is what was wrong. All right, but the next worksheet, I think you will have fractions. So just be aware of that, and we did something in class about that. Okay, so that takes care of the key to this worksheet.